Hello everyone. This is the third and last video on how to prepare for exams. The second video was very long and we talked about all sorts of different strategies to prepare for pretty much any type of exam. In this video, we will talk about strategies that are specific to problem-solving exams. So what are problem-solving exams? These are exams where you are asked to apply different processes to solve problems. So things like mathematical equations, also things like computer programming falls under this as well. So these are the sorts of classes where they are based on what's called STEM, so science, technology, engineering, and math. And so pretty much any math class will have these sorts of problem-solving questions, computer science and programming, engineering, things like physics, chemistry, sometimes biology, although biology is more things like factual information instead of like problem solving, oftentimes. Um, but things like this, physics, math, chemistry, programming, engineering, these are going to be the classes where the strategies in this video will be especially helpful. The last video will also be helpful, right? We talked about a ton of different stuff like how to overcome overconfidence, um, how to prioritize exams, how to think about what questions will be on exams. Those strategies will be helpful for anything, especially also the spacing effect and retrieval, right? So pretty much everything we talked about in the last video will help you with these courses, but this video will give you even more tips for how to study for these exams. The reason why I'm doing this video is because these sorts of courses, right, things like math, engineering, will oftentimes be the most difficult. Um, you know, in my experience, excuse me, in my experience in the United States, I told you all before that I first studied engineering and computer programming and then switched my major to become a teacher and teach government and history. So I have some experience both in like engineering classes, math, as well as like history and psychology. In my experience and like many other experience of students, in the US and probably in other countries as well, the uh, classes that have math are just going to be more difficult. Um, in my experience, so classes with math, things like chemistry, physics, engineering, math, programming, these classes are more difficult. One reason is because, sometimes the professors are just not very good at explaining information. And in those cases with those excuse me, with those professors, if they're not good at explaining the information, then it might just be better to find YouTube videos, go on websites that are free, like websites like Khan Academy where you can learn things like calculus for free, or just Googling on YouTube the topic that you're trying to learn about and finding a YouTube video that explains it. That's what I did a lot of times, many other people do. So sometimes these classes are difficult because the teachers aren't good. But honestly, oftentimes it's just because the difficulty is just on a different level. So a difficult math, let's talk about like homework, for example. A difficult math homework example in assignment in college could be, let's say I have five practice problems, right? This was very typical in my experience in college, right? I was very good at math when I was in like high school. Um, in college, what a lot of people find is that you're in a math class and you have five problems on a homework assignment. You might know how to do the first one or two, and then after like that, for some reason, like after the first one or two problems, you just don't know how to do the rest of the problems, and you need to go to like a tutor or a study group or office hours to get help. Um, and even for the students that were really good at math in high school, it's just more difficult. Um, Whereas a really difficult assignment in, let's say, a history class might be to write an essay. And writing essays can be difficult, but oftentimes, um, I know what to do for the essay, right? I know where I can get information. I know what I could research, what I can read. And really, it's just giving myself enough time to write the essay. Maybe I just literally don't know how to write the essay, but once I get some practice in writing essays, I know how to write essays. But oftentimes, in my experience and other people's experience, you'll find that you might do well in one math class, but then in a different math class, you'll have the same experience of just like you just literally don't know how to do the math problems because maybe they were not talked about in class, or excuse me, more often, maybe the questions on the homework assignments are just very different from what you practiced in class. Right, so long story short, these classes are going to probably be your most difficult classes. And everybody's going to have to take some of these math classes or classes like physics or engineering. Excuse me. You'll have to take some of these classes, especially in your first year. Like almost everybody will take calculus in their first year or second year. And so that's why I have this video to give you guys even more help because these are usually the most difficult classes. So first, I want you all, though, to retrieve your prior knowledge and experience. Excuse me. Think about how can you study for these sorts of exams? What do you already know? So take a second and pause and think about what you already know, and then I will share what I know. All right. Now we're gonna come back. You guys should know some stuff, but if you don't, then that is okay. I will share what we can do. First thing is everything we've talked about in the past videos, two videos in this week will apply, right? So do not reread your notes, do things like quizzing yourself, retrieval practice, do space practice, right? So practice over many different periods. Um, do not cram. Also everything else that we've studied in the past video, so things like avoid overconfidence by quizzing yourself, looking at past exams, past material to figure out what will be on the future exams. Just straight up asking the professor, like, what should I focus on studying for this exam? Just asking them is also an effective strategy. Probably the most helpful, really, for figuring out what will be on the exam. All of this helps. So some new strategies. This one we'll talk about like maybe five or so new strategies in this video, but this really is the most important thing is that you've got to do a lot of practice, right? So like I've said before, in college your time is very limited. You have to be very strategic with how you manage your time. And so some classes you have to spend more time in than others. In the classes where you know you have to spend a lot of time to really master the material, the best way to master this material in like a problem-solving based course like math or engineering, the best way is to just do a lot of practice. Um, and this is especially important because in the math exams or exams that have mathematical equations or things like programming algorithms, in these sorts of exams, you're going to be asked to transfer your knowledge. So what that means is transfer or apply your knowledge of like a mathematical equation from one context to another context, right? So being asked to solve a problem that still involves that mathematical equation, but it just looks very different. And these are oftentimes the most difficult kinds of questions, right? So how do you get better at transferring your knowledge from one context to another, to solving questions and problems that are more unfamiliar? It's just through practice. Um, that's really it. And the next strategies we'll talk about are going to be talking about how to effectively practice and strategies for better improving your practice and reflecting on it. But really, just the biggest thing is just doing a lot of practice. So, how can you get practice problems? You can look in textbooks. Oftentimes, in the textbooks that you will have in courses, there will be sections, maybe in the chapter or maybe in the back of the textbook, that just have practice problems. In my experience, not every problem in the textbook will be helpful. So really only a chunk, like a set of questions will be on the exam, and other questions just won't be covered. So consider what questions in the textbook will be helpful and what won't be. Then you can use those. You can also look for online practice. So, one resource that I recommend for practice is for the courses that you will take in the very first year that everyone mostly will be taking. So things like college calculus, things like college physics or college chemistry, things like that. These sorts of courses, there's a free website called Khan Academy, which I can share with you all on WhatsApp if you ask me to. But in Khan Academy, they have a very well organized set of courses that are completely free and give you practice on all the sorts of topics that you might find in a calculus class. So this is very beneficial for both practice and on Khan Academy. There's also videos that explain the content, so you can also watch those videos if you don't understand something as well. Um, so Khan Academy is one site, but you can also just Google things like, let's say I'm in, a calculus class and I need more practice on a specific topic. So let's say, one topic that you'll learn about is like derivatives, um, of a two-step equation or something. Um, you can Google, in the search bar those sorts of practice problems and find practice for that. And the last thing that you can do, and this is really, I would say the most beneficial thing you can do, is to ask the professor. So if you want more practice, just ask the professor, like, hey, I want more practice. I am struggling with this specific topic, right? So try to be specific about what you want more practice about, and just ask if they have any recommendations for resources, right? You can also do things like look at past homework assignments, past exams, and think about how you can use those to practice. But this is the best way to do it is I would say ask the professor and see if they have any recommendations. Okay, so the next big thing that you can do for improving your performance in studying for these sorts of exams is to compare examples of application problems. So what does this mean? So in these sorts of exams of like math or engineering, you will be asked to apply a mathematical equation in one problem, right? And it can be difficult to transfer that mathematical equation to a problem that looks very unfamiliar or different. And so you're just oftentimes asked, really the underlying thing you're asked about is your knowledge of how to transfer all these mathematical equations to different types of problems. So to understand how to do this, it's beneficial to just try and look at different examples of the mathematical equation and the application of that equation. Look at different examples and identify what is the same in those examples, right? So I think I have an example on the next slide. Yeah, so this is an example that you can do. So this is for a very simple mathematical question. Um, if we are learning something like trying to find the perimeter and area of different shapes in math, and we have word problems, right? Word problems are usually the most difficult. We can have practice problems like this and use them to compare the, you know, the mathematical equation, right? So one example here I wrote down is a farmer wants to build a fence around their yard. The yard is 10 meters wide and 15 meters long on both sides. How long is the fence? Right, so this question is asking me to transfer or apply the mathematical equation for the perimeter of a rectangle, right? So the equation I would use is the perimeter of a rectangle. So in this second question, we have an engineer needs to build a stadium that's 100 meters wide, 100 meters on two sides, 150 meters on the third side, and 200 meters on the fourth side. How many meters of wall does the stadium need? So these are two different questions, but really they both require the mathematical equation of perimeter, right? Of adding up all the different sides and the shape. And so if I was trying to study for an exam that involves equations like perimeter, what I would do is compare these two different problems and ask myself how they're similar, right? So, I'm asking myself how these two problems are similar. I recognize that these two problems are asking me to add up different sides in a shape, right? In this example, the first example, um, the two sides are the same, right? And then two sides are also the same. In the second example, um, two sides are the same length, but then there's also two different sides with two different lengths, so three different lengths in total. So that's a difference. But I recognize here that um, both of these problems just ask me to um, add up the different size of the walls, right? Or I just recognize in general that these two problems are asking about um, the size of the different walls around this shape, things like that, right? So really asking myself what is similar. And then from this, I then recognize something like, oh, in equations or problems where I have to use the formula for perimeter, I can recognize that these sorts of questions involve me to add up the different sides of a shape, something like that, right? So just asking myself these sorts of questions for what is similar and what's different, and recognizing what are the underlying similarities between different problems. So that is one way that you can better understand how to transfer different equations to different problems. Okay, another way that you can improve your practice is to do what is called interleaved practice. This is when you are mixing up different types of problems, right? So a very simple example is when you all were in elementary or primary school and you were learning very basic addition and subtraction problems. To improve, let's say you were trying to study for an exam in elementary school, which I know is like you probably didn't have to take an exam in primary school, but just as an example. And this exam is on addition and subtraction. With interleaved practice, what this says you should do, and this is based on a lot of research studies, is first get some practice with only addition, then get some practice with only subtraction, and then once you feel comfortable with addition and subtraction, mix up addition and subtraction, right? The reason why this is beneficial, one reason why, is it better helps you learn the difference between different types of problems and how to apply one procedure over another, right? So in more complicated examples, like this right here, so here we have four different volume equations. What I would want to do with interleaved practice is first be comfortable solving problems for each of these equations, right? So I should be comfortable solving equations for or solving problems with the first equation, the first one spheroid volume. Excuse me. I should then be comfortable solving equations just for the solving problems for the second equation, so the wedge volume. Then going on to the third equation, I should be comfortable with problems with that, and the fourth equation. And once I'm comfortable with each of these equations, I should then mix up these problems. And the reason why this is beneficial is when I mix them up and I'm practicing, I have to not just um, answer these questions and uh, go through the steps of these equations, but for each question, I have to figure out what equation I have to use, right? Whereas before, if I'm just solving problems on using the wedge volume equation, I don't have to figure out what equation I have to use because I already know that all the problems require the wedge volume equation. But if I mix up all these different equations, I have to figure out what equation I have to use. And through figuring out that step, I better transfer my knowledge and better see when I have to use each equation. And that's really important because oftentimes in these exams, we have to figure out what equation I have to use. The exam won't tell us what equation. We have to figure that out for ourselves. So this sort of interleaved practice is really important. This is a very effective strategy. Another example is if you're studying for a calculus exam, you're going to find many different types of problems that relate to calculus. And so when you're in this situation, you want to mix up different types of calculus problems. And textbooks typically will have practice problems for each chapter. So in these textbook problems, you can mix up these different problems to practice. Okay, now we'll go on to the next strategy, which is called self-explanation. So this is a method to really thoroughly explain to yourself what you are doing when you are solving a mathematical equation, excuse me, and not just a mathematical equation, but also things like programming something with a complex algorithm, things like that. With this strategy of self-explanation, you really want to unpack what you are doing in each step, right? So asking yourself, why am I using this procedure? How did I pick this procedure? How did I pick this equation? Maybe you want to ask yourself things like, how is this procedure different from other procedures, right? So maybe you recognize, I only want to use this equation in certain scenarios, right? So these sorts of questions. So this is done to where you really are making sure that you are understanding why you're doing each step, that you understand how to apply the entire formula and why it works. Um, And this is also beneficial because when you ask yourself these questions of something like, why did I use this procedure? And maybe you find that you don't actually know why you're using this procedure, that's actually really important, right? That shows that you have a gap in your knowledge that you need to correct for. And so you might feel a little uncomfortable that you don't know the answer to these questions, but in the long run, it'll help you because you can then do something like maybe ask the professor during office hours, or maybe ask help from another person to try and figure this out. And so this combined with interleave practice and all the other strategies will help you get an even deeper understanding of the mathematical equations. Okay, next big strategy is to study worked examples. So this can be beneficial when you are confused and stuck with um, different types of problems. So worked examples, you can often find them on textbooks. You can also just Google them online. They are basically just worked out examples of different problems, right? And in these worked out examples, they will show you each step of the process, right? So they will show you, let's say we're talking about the quadratic equation. In a worked out example, they will show you the first step, the second step, the third step, and they will let you really study how that equation works. And so when you are stuck and you're just like, I just I just need to start over, I just don't understand even how to apply this equation. Looking through these worked examples in depth can be very helpful. And when you are looking at worked examples, you should ask yourself similar questions that we talked about for self-explanation. So these questions are things like, what is the purpose of each step in the procedure? Maybe you can ask yourself, maybe you're starting with step one, and before you go on to step two, maybe you can ask yourself to predict what you think step two will be, right? You can ask yourself things like how each step is done, why is this procedure chosen instead of other procedures, things like that. And again, the reason why we want to, excuse me, the reason why we want to ask ourselves these questions is when we're asking these questions, we are forcing ourselves to deeply think, and that will help us process this information, and get it into our memory. So here's an example of a worked out example, where I have a word problem that might be challenging if I was in like elementary school or primary school. And I can see that they have a picture that they drawn. I can see that they have each side of the shape labeled. I can study all the different steps that were used in this problem and learn how to solve problems like this in the future. Okay, so the other big strategy that we'll talk about is to learn why you get certain problems wrong. So whenever you do make mistakes, which will be inevitable when you are practicing, um, whenever you get certain questions wrong, ask yourself questions like, what steps do you get wrong, right? And maybe you'll find that, let's say we're talking about the quadratic equation. Maybe you are very strong with the first two steps, and it's really the third step that you get wrong. Then you know that you need to focus on getting the third step right and asking yourself, why is this third step so difficult for me? Right? So asking yourself what steps you get wrong is important. Also, what concepts or procedures do you have an understanding of, but you just have trouble applying to new context, right? So maybe if we go back to this past example here. So this example, this is a word problem on the perimeter equation. Maybe you know how to use the perimeter equation, right? You know that all you gotta do is add up all the sides of the shape. Maybe you know how to do that, but you just have trouble knowing when to apply this equation to different word problems. If that is your difficulty, then you might want to use a different set of strategies to overcome this, right? So maybe you want to do things like ask the professor, when do I use this equation? During office hours. Or maybe you want to do things like prioritize practice on a bunch of different practice problems, where all you do is just identify what equations you can use, right? So in this example, right, instead of trying to solve every single word problem that I have in a set of practice problems, maybe all I do is just read each practice problem, each word problem, and just determine what equation I would use. And I don't go through all the steps to solve the problem. I just write down what equation. So maybe I note down that I know that I need to use the perimeter equation for problem one, and then the area equation for problem two, and then volume for problem three, whatever it is. That way, I'm getting practice specifically on how to apply different equations, focusing on my most weakest areas. And then for one last question is for questions that you get wrong, do you get the question wrong because you picked the wrong formula or because you did the steps in the formula incorrect, right? So this is very similar to the second question. And if you get, like I've said, if you get questions wrong because you picked the wrong formula or equation, then do what I've said, right? Of look at different practice problems and just focus on identifying the formula, the correct formula. Don't focus on solving the formula and going through all those steps. Just focus your time on identifying the formula, because that gives you practice on what you need most. Okay, so that is pretty much everything that I have for how to study for math-based exams. And so this plus the past video will be very beneficial. I know it was a lot, and so like I've said always before, is pick what strategies are going to be most helpful for you. I would say the biggest things are asking the professor what you need to practice on. Don't cram, spread out your studying and do a lot of practice. Um, and then excuse me, from there, just gradually improving how you study for these sorts of exams using the strategies in this video. So now what I want y'all to do is take a second, stop and reflect, and answer this question. When studying for problem-based exams like math, I used to do blank. Now I will do blank. So take a second, pause, and think about what you will now do. All right. Now we'll come back for one more slide. I want to, because this was a lot of different information, and because math-based exams are usually the most difficult, I want to give one example that just kind of ties all of these different strategies or a lot of them together. So let's say I have an exam that is on physics. And this physics exam is on velocity, force, and friction. I've taken good notes, I've revised them. Now what I want to do is study for this exam. What I should do is make a to-do list on the topics I need most focus on, and this should be based on what the professor says will be on the exam, what I have asked the professor will be on the exam, as well as things like past homework assignments, things like that. And then I will plan out how I will space out my practice, right? Right? So, excuse me. Maybe I will determine that I need to study 30 minutes every weekday for the next 2 weeks, right? Or maybe I will spend 30 minutes every day for the next 3 weeks, right? Whatever it is. Um, and make my weekly, excuse me, make my weekly schedule. But definitely avoid cramming. So based on this, I then will plan strategies for how I will prepare for the exam. Maybe I will think about what practice problems I can use, where to get practice problems. Maybe I'll think about how to do interleaved practice. So how do I mix up different practice problems? And also I need to focus on things like how I can avoid procrastination, how I can have good focus, maybe put my phone away, things like that. So really trying to apply, try to apply everything everything we've learned for things like time management, good focus, procrastination, exam preparation. If you are able to apply all this stuff over a period of time, then this will be the best way that you can perform on exams. So that is pretty much everything. This we've already talked about. That's pretty much everything for this lecture series on exam preparation. If you need any more help or have any questions, please ask me, and I'm very happy to answer in WhatsApp. Hope you all have a great day.